Grade 12, let us continue the geniusness of understanding the IUPAC naming of aldehydes. Now, before we can get into the task at hand, allow me to share with you my observations. Because from where I am standing, it is clearly demonstrative that your poor performances are evident to the actuality that your educators have the audacity to allow you to walk into the examination room fully unprepared, because they've been doing that from term 1 to date, hence your poor performances. Now, you should, every time when you're studying, ensure and make sure that you study with NETA, so that NETA can be able to push you in the direction of level 6 and level 7, so that NETA can stop that nonsense of walking into the examination room fully unprepared. We want to prepare you and make sure that we fully prepare you in a manner that you will be able to achieve level 6 and level 7 in your physical sciences, mathematics, and other subjects. Now let us continue with the homologous series at hand. We have the homologous series of aldehydes, and I want us to look at a certain structure. Let us stress the understanding of this structure of aldehydes. 1, 2, 3, 4. The structure of aldehydes. Now remember that whenever you are engaged in the activity of IUPAC naming, there is a principle that should always be followed, and a principle that should never be allowed to not be followed, because if you don't follow this principle, you will always go wrong. Remember that the number of carbons must be shown in the IUPAC name. The manner in which you are naming your structure is the manner that follows the amount of carbons that you have in the structure, in your structural formula. And if you have 1 carbon, you will indicate that with the prefix of meth. 2 carbons will be demonstrated with the prefix of eth, while 3 carbons will have the prefix of prop, where 4 carbons will have boot, where 5 carbons will have pent, and 6 carbons will have hex. So this is your IUPAC naming. The name shows the arrangement and the amount of carbons in the structural formula. It shows the manner in which the carbons have been arranged and the number of carbons that are available in the structural formula. Now remember that the first thing that we have to establish is for us to establish a parent chain. And always remember that your parent chain is a chain that has the longest chain, is the chain that has the highest number of carbons. Now let us start counting, and the rule says that we have to start counting from the functional group. Remember, this is the formyl functional group. Now whenever we count the highest chain, the longest chain, then we have to declare it our parent chain. Let us start counting. 1, 2, 3, 4. Now you cannot stop here, because after this carbon there is still another carbon that is connected to it. You have to proceed to that carbon until when you're counting you won't be having any carbon on the chain. Now when you start, you're going to, when you count, you're going to say 1, 2, 3, 4, 5, because this is the last carbon. It means this is your chain. Now whether it's the longest chain or the shortest chain, we have to check the other one so that we can compare. Now let us check another chain. 1, 2, 3, 4. Now this is the chain with 4 carbons, and this is the chain with 5 carbons. It means this is your longest chain. And if it is the longest chain, then you have to immediately declare it as your parent chain. And this is where the naming begins. Because there are 5 carbons in this parent chain, it means we're going to have, not boot, we're going to have pentanal. which is the indication of the parent chain. It tells us that on our parent chain we have 5 carbons, because pent is a demonstration of 5 carbons. It shows that 1, 2, 3, 4, 5, we have 5 carbons. And there is another chain that is emerging from the parent chain, which must also be accounted for together with its position. Now, you can see that the emerging chain from the parent chain is the chain with only 1 carbon. And if there is a chain with only 1 carbon, it means we have to use a myth to demonstrate that our branch chain is a chain that only contains 1 carbon. And we're going to do that by saying methyl, which comes from meth, which is the indication of 1 carbon. And the position to which this branch chain is situated must also be accounted for, which means that we have to tell the story of where does in our parent chain the side chain connected to. Let us check. 1, 2, 3. It is connected to the 3rd carbon of the parent chain. We have to include that. It means that the name of this structural formula is 3-methyl pentanal. That is how we name our aldehydes that has side chains. And whenever you might have not understood any of what we are doing, please ensure that you submit all of your confusions and submit all of your difficulties to NETA, so that NETA can be able to study with you, with the objective that you walk into the examination room fully prepared and with the full understanding of how to deal with your questions. Because if you want to attain level 6 and level 7, you will study with NETA. Your educators have clearly demonstrated that they have no intention of ensuring that you achieve level 6 and level 7. Please make sure that you come to study with NETA.